So we would like to move into chapter 5, and most of chapter 5 is going to be about exponential and logarithmic functions. But the first two sections of chapter 5, 5.1 and 5.2, they're sort of a prelude to exponential and logarithmic functions. It's about composing functions and inverse functions. So we want to discuss the idea of composing functions. So we're going to start off with a definition of what is composition of two functions. This is a way to combine two functions that are configured in a certain way with their domain. So let's suppose you have two functions f and g. Suppose f and g are functions where x is in the domain of g and g of x is in the domain of f. Okay, so that's kind of the background information. So I want to draw this out. So you have these two functions. So the first function here, I'm going to call this function g. So g is like a machine. And you have another function here we're going to call f. F is like a machine. And the idea that we have is you have two functions, f and g, and x is an input into g, right? It's in the domain of g. So back here you have the collection of all the inputs. We call that the domain for g. So you're allowed to plug x into g. Now what happens when you plug x into g? Well, out the other side comes the output, which we often call g of x, right? Now what else do we know? We know that g of x is in the domain of f. So you can plug g of x into f. So back here in front of f, we have everything that you can plug into f. That's called the domain of f. So g of x lies in there. Okay, so x goes into g, and out comes g of x. G of x is going to go into f, and out the other side is, what's going to come out the other side? The output will be f of g of x. Okay? And that's what's going to happen. So what we want to do, we want to define a function, basically. A function where you can go directly into this machine, this function, from x, and get directly to f of g of x. So basically, going through this one machine would be the same thing as going through these two machines. So this kind of speeds up the process. And we're going to call this function the composition of f with g, and we're going to write it f circle g, like that, f circle g. So this is called the composition of f with g. So going through f circle g sends you to f of g of x. That would be the same thing as first going through g and then going through f. So we want to define this properly. That's basically what's going to be happening. What do we want to say? The composition of f with g, that's what we're defining, is going to be denoted f circle g. That's that new machine down there. I'm going to make it yellow here. That new function called the composition of f with g, denoted f circle g, is defined by f circle g of x. Yeah, so the idea here is you're plugging a red x into this machine. That's what we're doing. We're plugging a red x into our yellow machine. Equals, out the other side comes f of g of x. So that would be your output that I'm underlining in blue. So that's this right here. So you plug in a red x into the yellow machine, and the output is a blue f of g of x. I thought that was a gunshot for a second. I think it's just kids playing with fireworks. All right, so that's the new operation we're going to be dealing with between two functions called composition. So let's do a few examples. Exercises. So let's say I have two functions. We'll consider the two functions. F of x, which f of x is going to be 4x squared plus 7x plus 8. And the other function here, g of x, is going to be 9x cubed minus 2x squared. So we have two functions, f and g. The first thing we want to do, so we want to do the evaluations of the following. So evaluate the following. And number one, we want to evaluate simply f of minus 11. And then number two, after we do that, we want to evaluate g of minus 1. And then after we do that, we want to do a 3. We want to evaluate f circle g, or f composed with g of negative 1. Okay, so f of negative 11, what does that mean? So I'm going to call my f function red, and I'm going to call my blue function g. G is going to be the blue function. So for f of negative 11, I'm just plugging negative 11 in for x in the red function. So I'm going to have here 4 times a blank, if I can get this to write properly, 4 times a blank squared plus 7 times a blank plus an 8. I'm going to plug in a minus 11 for x. If you do your order operations correctly, you're going to have 4 times negative 11 squared is 121. You're going to have 7 times negative 11 is negative 77, and we're going to have plus 8. If you do 4 times 121, you're going to get 484 minus 77 plus 8, and let's see, what is that? I think that's 415. Let me plug that in a calculator. Yep, 415. All right, what else do we want to do here? Okay, we want to do this g at negative 1, g at negative 1. So I'm going to use blue function g. I'm going to do 9 times a blank cubed minus 2 times a blank squared. We're plugging in negative 1. So remember, order of operations say exponents come first, so I'm going to do the negative 1 cubed first. I'm going to do 9 times, what's negative 1 cubed? It's negative 1. And we're going to do minus 2 times, what's negative 1 squared? It's 1. So now I have 9 times negative 1 is negative 9, and then negative 2 times 1 is negative 2, so I get negative 11. Okay, so now I got to do f composed with g of negative 1. You have a f composed with g of negative 1, and this should be blue, the g. Okay, so remember how that's defined. That's defined to be, go back and look at how you define the composition of functions. You start here with the f, and then inside you're going to put the g of x. We're going to write this as f on the outside. So your left function, your function on the left, which is f, that goes on the outside, f. And then on the inside, you're going to have g of, and then you put in your x value inside of the g function, negative 1. If I want to compute this, I'm going to leave the outside function alone for now, and I got to find what g of negative 1 is on the inside of f. So g of negative 1, that means, hey, you know we actually calculated this already. G of negative 1, we've actually calculated as minus 11. So the answer there is minus 11 for g of negative 1. So now that we have negative 11 inside of the f function, now we have to find out what f of negative 11 is. Well, actually, we already found that out back here, right? We know what, if I can get that in red, we already know what f of negative 11 is. It's 415. So our answer here is going to be 415. So the input into this composite function is -1, right? That's the input, -1, and the output is 415. All right, let's do another example. So that should have been a little 3 there, not a little 2, but a little 3. Don't know what happened. Okay, let's do a little 4 here. Let's say we wanted to find G circle F, or G composed with F of -2. So this time we have the blue function on the left and the red function on the right. And our input is -2. So what I'm going to do, I'm going to start from the left, and I'm going to write G on the outside. And then on the inside of G, I'm going to put the function on the right, F. And then inside of F, I'm going to put the input of -2. So you always leave the outside function alone initially. And you're going to work inside of the G function. You got to find what F of -2 is. What is F of -2? Well, F of -2, you're going to have to use your red function. So you have what? 4x squared plus 7x plus 8. We're going to plug -2 in for x. So we're going to 4 times blank squared plus 7 times blank plus 8, right? That's the F function. And in place of x, we're plugging this green -2 here. So we have G of, let's figure out what this is. We're going to have, do your exponent first. 4 times -2 squared is 4. And then we're going to have 7 times -2 is -14 plus 8. So we end up getting G of, let's see, 4 times 4 is 16 minus 14 plus 8. What's 16 minus 14 plus 8? It's 10. So I'm going to have G of 10. Okay, so now I have to find G of 10. How do I find G of 10? Well, I'm going to take 10 and plug it into the G function. What's the G function? 9x cubed minus 2x squared. So 9 blank cubed minus 2 blank squared. So in place of the x, I'm going to plug in this red 10 right here. So here goes a 10, here goes a 10, and we're going to end up with, let's see, 9 times, what's 10 to the third power? That's 1,000, right? Minus 2 times, what's 10 to the second power? 100. So I'm going to take 9 times 1,000. I get 9,000 minus 2 times 100 is 200. I'm going to get 8,800. Okay? So plugging -2 in first to the F function, getting an output of 10, and then taking 10 and plugging it into the G function, getting an output of 8,800. Okay, so let's say we don't want to plug in numbers into our composite functions. So we just keep our variables as x. So let's say I wanted to find, for example, f circle g of x. F circle g of x, like that. F composed with g of x. So remember, f is red, g is blue. So how I'd start this, I'd start with writing my left function, the f on the left, putting a big parentheses, and then writing the g inside of x. Now, since we're not actually plugging in a number for x this time, since we're leaving it a variable, what we'll do, we'll leave the f on the outside, and in place of the g of x, we'll actually put the function that g of x is. So we're basically going to replace this g of x here with 9x cubed minus 2x squared. 9x cubed minus 2x squared. Okay? Now, we can't simplify that 9x cubed minus 2x squared. I mean, if you want to try factoring that, you could, but there's really no point to factor that. That's not the goal here, to factor. What we'll do next, we'll take this blue expression, 9x cubed minus 2x squared, and we'll plug that into the f function in place of the x. So our f function is 4x squared plus 7x plus 8. So I'm going to do 4 blank squared plus 7 blank plus 8. Is that right? 4x squared plus 7x plus 8. Yes, that's right. And in place of where the x was, those blanks, I'm going to put the blue stuff. 9x cubed minus 2x squared, 9x cubed minus 2x squared. Now, you can simplify this a little bit if you like. I mean, it's fine to just leave it like this in this black box. But you don't want to simplify it too much because it can get really tedious doing the expansions. So what I'm going to do, I'm just going to distribute here this 7. I'm going to distribute this 7 through. I'm going to leave the other stuff alone. I'm going to have 4 times, in parentheses, 9x cubed minus 2x squared. I'm going to close that parentheses and put a square. I'm not actually going to do that red squaring. I'm not going to expand that. It would be a little tedious. But here we can expand with the 7. We can distribute the 7. We'll get, let's see, 63x cubed minus 14x. And then we have a plus 8 on the end. I think that'll be good enough for our expansion. So don't go all out on your expansions. I'm not really interested in seeing that you can expand things so much. I'm more interested in seeing that you know how to correctly plug in to these to get these composite functions. All right, let's do one more example of composing functions. Let's do this time g circle f of x. G composed with f of x. So first we're starting with the g, right? So when we write this out, we're going to have g first in blue, and then inside we're going to have the right function f of x. So I'm going to leave the g alone on the outside, and inside I'm going to put what f of x is. What is f of x? If you remember, f of x was 4x squared plus 7x plus 8. I believe that's right. Yeah. Okay, so I really can't simplify 4x squared plus 7x plus 8. So now I'm going to plug that red stuff into my blue function. Now, what was my blue function? My blue function was 9 times n blank cubed minus 2 times a blank squared. And in place of where the x was into the blue function, we're going to put the red stuff. 4x squared plus 7x plus 8, 4x squared plus 7x plus 8. And if you wanted to try expanding that, you could, but it would be very tedious, so we're not going to expand it. We're just going to leave it like that. Okay? Yeah, so there is composing functions. So this would be in our book, this would be section 5.1, where